Welcome to the Tech Life Well podcast. We're delighted to have you with us.
Where we make technology simple, thoughtful, and useful. For more insights and episodes, visit techlifewell.com.
Welcome back to The Deep Dive. Today we're accelerating way past simple chatbots, the AI that just responds to prompts. We're diving deep into systems that set their own goals, create their own plans, and execute really complex workflows without asking for permission. We are talking about true autonomy.
That's exactly right. For this deep dive, we're unpacking a really powerful stack of source material, and it's all focused on Agentic AI.
Right.
Our mission is to clearly define what this revolutionary tech is, understand the critical difference between the tools and the orchestration, and walk through the 5-step continuous cycle that lets these systems operate with a high degree of independence.
And it's worth noting, before we even get into the complex stuff, the foundation here.
Yeah.
Our sources make it really clear that none of this would be possible without those foundational breakthroughs in, natural language understanding.
Absolutely. That work, a lot of which was established by early research on large language models at places like MIT, laid all the groundwork.
So that core capability, that sort of thinking brain, is now being connected to the real world.
Exactly. And that brain is ingesting information from everywhere.
Yeah.
From highly organized databases, what we call structured data,
Okay.
and also from the messy, complex world of documents, emails, sensor readings, unstructured data.
And that combination is what lets it move from just outputting something to actively managing real-world tasks.
That's the leap from output to action.
Okay, let's unpack that. We have to start by defining what agentic AI actually is. Because if generative AI is busy creating content, what is agentic AI adding that makes it so autonomous?
The core function shifts from creation to action. Agentic AI is an advanced form of AI that's really focused on autonomous decision-making and then execution.
Right, not just thinking, but doing.
Exactly. Unlike traditional AI that just follows a specific instruction, agentic AI can define its own approach, formulate a plan to achieve a broad goal, and then execute it with minimal human intervention. Its whole purpose is to automate entire chains of complex business processes.
That sounds like a massive jump in capability, and I think we need to clear up some vocabulary right away because AI agent and agentic AI get thrown around a lot.
They do, and our sources draw a very sharp line between them.
So what is it?
It's a subtle but vital difference. AI agents are the specialized building blocks. Think of them as individual, highly capable workers designed to do one specific singular thing.
Like calculating the best shipping route or querying a database.
Precisely. An AI agent is a tool, but it's not the overall strategist.
Okay.
Agentic AI is the overall system. It's the overarching intelligence that coordinates and manages multiple specialized agents to handle a complex end-to-end workflow and achieve that bigger business objective. It's the manager of the agents.
I think that house-building analogy from the source material is perfect for this.
It really is.
Yeah.
The AI agents are the individual tools in the toolbox, a hammer, the saw, the level.
Each one does its job really well.
Right. But agentic AI is the master builder who coordinates the use of every single one of those tools, making sure they're used in the right order, in the right combination, to successfully build the entire house, from the foundation all the way to the roof.
I see. So it's the conductor of the orchestra. But how does this relate to generative AI, Gen AI, which is what everyone is familiar with right now?
Well, Gen AI, as you said, focuses strictly on creation. It takes a prompt and it generates new content. Text, code, an image, maybe some music. The large language model is the core engine, and its value comes from that creative output.
And some simple extensions, right? Like function calling.
Right, which lets it use an external service based on a prompt. But it's still fundamentally waiting for us to tell it to create something.
Whereas the agentic AI is the one deciding when, where, and why to use that creation in the first place.
That is the crux of it. Our sources define agentic AI as a subset of generative AI. It uses the LLM as its primary brain for reasoning, but its whole purpose is the orchestration and execution of actions in other systems using its agents and tools.
It's the shift from simply creating an answer to actively doing something with it.
Yes.
Can you give us a concrete example of that?
Sure, let's stick with a marketing strategy. If you task a standard Gen AI, it will write a great headline, generate the ad copy, maybe even design an image. And that's where its job ends.
Okay.
An agentic AI, on the other hand, takes that new content, deploys it across social media and email, automatically tracks the click-through rates in real time, analyzes the results, and then, this is the critical part, it adjusts the budget, or the targeting, or even the copy itself based on what it learns.
So it's taking continuous autonomous action to hit a business goal.
Exactly. It's a continuous optimization loop.
That shift from just output to continuous action it's genuinely enormous. Which brings us to the mechanics. The source material lays out this continuous 5-step cycle that allows this to happen. What's the first stage? Where does it start?
It all starts with perception. Before anything else, the system has to become aware of its environment.
So it's gathering information.
It's gathering information from everywhere. Sensors, transaction logs, databases, user interfaces. It's analyzing all forms of data, structured and unstructured, to build a complete picture of the current situation.
It's like the AI's version of opening its eyes and just observing the world around it.
That's a great way to put it. Then comes step 2, reasoning. This is where that LLM brain really kicks in.
The thinking part.
The thinking part. The AI analyzes all that data it just perceived, it establishes context, it filters out the noise, identifies the relevant bits, and then formulates potential solutions to the problem at hand.
So it's like a human taking a bunch of scattered information and turning it into a coherent problem statement.
It's a perfect parallel. For example, if the goal is to schedule a complex international meeting, the reasoning step is parsing all the emails, figuring out who needs to be there, what time zones they're in, and what the meeting is even for.
Okay, so once it's done, it's thinking. The next logical step has to be getting organized, right?
That's step 3, planning. Based on its reasoning, the AI develops a cohesive sequential plan. It sets the main high-level goals, and then it breaks them down into smaller executable steps.
And it figures out which tools, which agents it needs to use.
Exactly. It determines the optimal agents and tools and puts them in the right order.
And then we get the payoff.
Step 4 is action. The system executes the plan. It performs tasks, makes decisions within its approved limits, and interacts with other external business systems, often by deploying those specialized AI agents we talked about.
Now, this next part is what really defines the leap for me. The system doesn't just execute and stop. It has to learn. Step 5.
Absolutely. The final and I'd argue most profound step is reflection. After the action is done, the AI evaluates the outcomes. It asks, was that successful? Did I meet the goal?
And it learns from that feedback.
It learns from positive or negative feedback and uses that insight to immediately adjust its future plans and actions. This creates that continuous self-improving loop that gives it true autonomy.
That reflection step sounds like the most powerful and maybe the riskiest part of this cycle. If the AI is constantly learning and adjusting its own strategy, how do organizations stop it from, drifting outside the ethical or business guardrails they set up?
That is the fundamental governance challenge. The system is designed to refine its strategy to reach the goal, not redefine the goal itself. But you've hit on exactly why robust monitoring is so critical.
Can you give an example?
Sure. Imagine a supply chain system reflects that by violating a low-priority contractual term, it gets a small efficiency gain. A human has to audit that reflection loop to prevent what we call mandate creep. The goal is still efficient delivery, but the system's learned method has to be checked against human policy.
That continuous learning loop completely changes the game. So what does this level of self-management mean for the real world? I mean, where are we actually seeing this kind of autonomy being applied today?
We're seeing it penetrate critical sectors really quickly because this ability to orchestrate just maximizes efficiency in these complex multi-stage jobs. Let's look at a few examples.
Okay, let's start with the financial world. Fraud detection is famously complex. How does agentic AI help there?
In financial services, you can think of it as an end-to-end risk strategy agent. The perception step is continuously gathering millions of transactions, market signals, customer data.
A huge amount of data.
A massive stream. The reasoning component then analyzes that stream to find subtle anomalies, things that simple rules-based systems would totally miss. If it detects a potential fraud spike, it then plans a multi-tiered response.
So it doesn't just flag it.
No, it acts. It might block the transaction, notify the customer via another agent, and immediately update the risk modeling parameters in the core system all at once.
And then the reflection piece ensures that if that specific fraud pattern shows up again, the system is even faster next time.
Precisely. It uses reflection to refine its understanding of new threats, constantly improving the speed and accuracy of the next decision. It's automating fraud mitigation in real time.
Okay, let's look at supply chain management. That's an area famous for complexity, unpredictable global events. How does the 5-step cycle play out there?
This might be the best real-world example of goal orchestration. Let's say the main goal is timely delivery of specialized components.
Okay.
The perception step detects a sudden, massive shipping delay at a key port because of some unforeseen global event. The reasoning agent immediately calculates the potential impact on, say, 15 downstream manufacturing plants.
That's a huge, complex calculation for a human to do quickly.
Exactly. And it also assesses alternative component sources and logistics routes. Then the planning component kicks in, creating a detailed rerouting strategy, maybe shifting production, sourcing a temporary part from a backup supplier, and dynamically booking new air freight.
And the action agents execute all of that.
They place the new orders, adjust the customs paperwork, notify all the affected plants.
And the reflection.
The reflection component uses this whole disruption as a learning event. It updates the core supply chain model with the probability of that specific type of disruption, making the next plan even more resilient. It can preemptively hedge against similar risks in the future.
That deep level of autonomous action means we absolutely have to talk about governance and trust. I mean, if an AI is setting goals and adjusting its own strategy, the human oversight has to be incredibly robust.
It absolutely must be. Given this move to autonomy, implementation requires rigorous oversight. And that starts with the prerequisites. First, the business has to have clear objectives that align perfectly with business strategy.
Right. If you tell it the wrong goal, it'll get very good at doing the wrong thing.
Precisely. If the goal is just revenue, but the real value is customer retention, the AI will optimize for the wrong metric.
And we've said it before, the system is only as good as the information it gets. Data integrity is foundational here, isn't it?
It is everything. The systems rely entirely on data quality and preparation. The data has to be accurate, complete, up to date. If there are biases or errors in the training data, say historical lending data, the autonomous system will learn those biases and embed them into its actions.
So data prep is a huge part of the work.
It's the most critical and often the most tedious part of deployment. And to handle all that data, both the messy unstructured stuff and the clean structured records, it needs specific tools to work efficiently.
That's the retrieval stack you mentioned.
That's the retrieval stack. Think of it as the AI's sophisticated librarian. It's essential because the agent needs to quickly and accurately pull context from millions of documents and database entries for its reasoning phase. Without good retrieval, the agentic AI would just be guessing.
Let's talk about security directly. I mean, systems that can execute actions are huge targets.
Huge targets. Security is paramount. Robust measures are mandatory to protect against cyber attacks, data breaches, anything that could compromise the integrity of the agent's decisions.
Especially when it can execute a trade or shut down a supply line.
Exactly. You need strong governance policies enforced to monitor the model's compliance with all those security and business rules.
Okay, finally, let's talk about trust and explainability. When an agentic AI makes a high-stakes decision, especially when something goes wrong, we have to know why it decided that way. How do we pull back the curtain?
That's where explainability techniques are mandatory for trust and debugging. Our sources cite two specific powerful ones, Shape and Lime.
Can you just quickly clarify what those actually do for a user beyond just the names?
Absolutely. So think of the AI making a complex decision, like approving a big industrial loan. That's the black box.
Yeah.
Lime, that's local interpretable model agnostic explanations. It essentially creates a detailed explanation card for that one decision.
Okay.
It tells you which three specific inputs, say annual profit, debt ratio, and years in business, were the deciding factors for that single loan approval. It gives you localized transparency.
So it breaks down the complex output into human-readable reasons for a specific moment in time.
Correct. And SHA, or Shapley Additive Explanations, does something similar, but provides a more globally consistent framework. Both of them ensure that even if the underlying model is incredibly complex, the output is auditable. You can check that it's relying on relevant data, not something biased or random.
And all of this, performance, security, governance, it needs continuous active management, right? Especially since the reflection step means the system is always evolving.
It does. And this is where MLOps machine learning operations tools come in. MLOps is basically the DevOps for autonomous AI. It ensures continuous monitoring of agent performance, it manages version control, it automates fixing issues, and it refines the algorithms as the system learns, keeping it stable and compliant in a live environment.
So to synthesize this deep dive for you, Agentic AI is that leap from just generating content to actually executing complex autonomous business strategies. It's defined by its ability to perform the full continuous cycle of perception, reasoning, planning, action, and reflection. It is the orchestrator of agents.
And we've established that this orchestrator is designed to manage these complex tasks and continuously learn and adjust its own strategy. Given that autonomy, here's the final provocative thought we want to leave you with.
Okay.
If agentic AI systems are performing complex tasks across multiple businesses, say a finance agent communicating with a supply chain agent, and one of those agents identifies a new non-compliant method during its reflection phase that happens to yield superior short-term results,
Hmm.
who or what is ultimately responsible for detecting that drift? And how quickly can a company enforce a global policy update across dozens of these learning autonomous systems all at the same time?